Okay, today you're going to be doing lesson 11.6, rational expressions with like denominators. You can go ahead and put this in your table of contents and add it to your title page. The sub can go ahead and hit pause. Okay, so our main idea is that we're just looking at rational expressions with like denominators, and then we're going to also subtract those. We're going to add and subtract them. Alright, our first example is 4b over 15 plus 16b over 15. So now you'll notice that they do have the same denominators. Remember, the denominator is the bottom of the fraction, and that number down there is the same. So we can just add straight across on the top and leave the bottom as 15. And so now I apologize, I'm trying to write on my iPad and that doesn't work very well. And so you'll just have to deal with my messy handwriting here. So 4b, oh, that's not good, sorry. So 4b plus 16b becomes, just a second here, let me try to find my pen. Let's try that, okay. Is 20b, again, I'm sorry, this is bad, over 15. Well, then we look to see, can we reduce 20 over 15? And they're both divisible by 5. So if we divide them by 5, we get 4b over 3. There's our, ooh, that didn't look up good. Let's see, find the undo button. Where's my undo? Okay, 4b over 3. We'll just leave it as that. All right. So try one of those on your own. Go to your left page. The sub can hit pause here, and then when everyone's done, you can hit play again. Okay, let's run through this. They both have a denominator of 9. And so we can just take 7 plus 17, which is 24, k over 9. And what can 24 and 9 both be reduced by? We could take a 3 out of both of them. If I take a 3 out of 24, I'm left with an 8. Still have the k up there. And then 9 divided by 3 is 3. Oh, that was a 3, but it turned out it looks like a 1 instead. Try that again. Take my eraser. This isn't going as fluidly as I was hoping. Oh, that's not a 3 either. Okay, try again. Let's do it really slow motion. There we go. There's our 3. And so our answer is A. Okay, let's try our next one. So now you'll notice that we have a binomial in the denominator because it has 2 terms, c plus 2. But they also still match, so we're just going to add the tops like normal. So if we add 6c plus 12, we can't actually add those two together and get 18 because one has a c and one doesn't. They're not like terms. So what we're going to do is just write 6c plus 12, oh come on, there we go, divided by c plus 2. Now it appears that should be the answer, except for the fact that I noticed that the numerator, the top, has something in common. What do they both have? They both have a 6, and so we can factor out a 6. I'm going to give myself some room by sliding that over. And so if I factor out a 6, oh, I have to find my pen again, sorry. That's going to equal 6 parentheses. What's left over? Out of the first term, I only have a c. On the second term, if I divide out a 6, I'm left with a 2. And on the bottom, I still have c plus 2. Now, do you notice any whole groups that can be canceled out? I do. I notice that that group cancels out with that group. And so what do we have left over? Just that 6. So our answer is 6. So that whole complicated thing can be reduced down to just 6. Okay, let's try that on your left page. Try this problem. Again, the sub can hit pause, and then when everyone is finished, hit play again so you can see the problem worked out. Okay, so let's work this one out. Again, the denominators are alike. The numerator can be put next to each other, but you cannot actually add them to make 25. Now, do they have anything in common? Yes, they both have a 5. So pull a 5 out. I'm sorry, it's not looking very neat. What's left is a y plus, what's 20 divided by 5? 4 over y plus 4. And what do you know? The same thing happened as the last time. So we can cancel these out. Y plus 4 cancels out the y plus 4, but the line and the 4 didn't show up. There we go. And what are we left with? Just 5. So D is our correct answer on this one. Okay, the next problem is a perimeter. So this one's probably going to have to hit pause so you can write down the shape and the expressions for each side. All right, and perimeter. To do perimeter, what we do is we add up all of the sides of the triangle. It's like building a fence. How much fencing do we need? Well, we would just have to add this side, plus this side, plus this side, plus this side. So we're going to add all those two together. So let me see. I'm going to hit pause for a second and see if I can write that out a little nicer without having to try to handwrite it. Okay, as you can see, I cheated a little bit. The sub's probably going to need to hit pause so you can write down everything that I've just added to it. I've taken the 2 longer sides plus the 2 shorter sides, and we're going to add all 4 fractions together. So the sub can hit pause now. Okay, then we're going to add these all together. So let me grab my pen again. Now I notice that all of the denominators are the same, which is 2x plus 7. Oh, that's an ugly 2. Try that again. I'm not sure that's any better, but we'll go with it. Plus, I think I said 7. What was I thinking? 2x plus y. All right, now we're going to add all of our x terms together. Still, I notice, let me see if we pull the highlighter here. I've got a 5 and a 5 and a 3 and a 3. So if I add all of those together, 5 plus 5 plus 3 plus 3, back to my pen, that's going to be 16x. And now let's go a different color highlighter. I'll go with this pinkish color. Add my y's together. 4y plus 4y plus 2y plus 2y. That's going to make 12. Plus 12y. Alright, I notice that the top has something in common we can factor out. What do they have in common? What's the biggest number that I can pull out of both of them? The biggest number I can think of would be 4. And I have left 4x plus 3y. This is getting ugly. And it's all over 2x plus y. Can anything cancel out at this point? No, it cannot. So that is our final answer. I'm not even going to attempt to circle this one. Alright, back to your left page again. Again, the sub can hit pause so that you can try this on your own, and then hit play again to show the answer worked out. Okay, so same thing again, we're going to have to add up all of the numerators. The denominator is the same, so I know the denominator is going to be 3a plus 4b. And just to make it a little easier, I'm going to put the fractions on all 4 sides of the rectangle. And by the magic of the pause button, they all show up there, and let's add up our a's together. So we've got 2 and 7 and 2 and 7, so 14 plus 14 is 28. And let's see if I can do an 8. Ooh, look at it, I did it, 28a. And now we can do our b terms. Go green. 5b and 4b and 5b and 4b is 18. Plus 18b. Okay, now I'm guessing that they have something in common. So let's think about what 28 and 18 have in common. Oh, I made a mistake. I don't know what I was thinking when I was adding 14 plus 4 and got 28. It is actually 14 plus 4 is 18. Make it a lot better here. So fix this. 18. There we go. They both have an 18 in common. Now it's going to look like it matches up one of my answers. Oh, that's my attempted 8. Try that one again. It's slow. Nope, there it went. Oh, good. So I'm factoring out to 18. If I pull 18 out of the first one, I'm left with an A. 18 out of the second one, and I'm left with a B. And on the denominator, I still have 3A plus 4B. So which one comes out correct? That looks like A. Okay, let's do some subtraction now. So subtracting works the same thing as adding. We just need to have like denominators, except for we're going to subtract the tops rather than adding it. So copy this expression down, and then the denominator is going to be the same, x minus 3. But this time we are going to subtract like terms. So get our highlighter out again, we'll go blue. 7x minus x. Remember there's like that 1 in front of it, and if you want, put the 1 in front of the x. And we get 7 minus 1 is 6x. Okay, now you do the same thing for the other terms. 9 minus negative 5. Now be careful with that. Minus negative 5. Minusing a negative becomes adding. So that's going to be 6x plus 14. Okay, do they have anything in common? Yes, they do. They have a 2 in common. Pull out a 2. What's left over? 3x plus 7 divided by x minus 3. Can anything cancel out? Nope. That's our answer. Okay, let's try another one. So copy this one down. So the denominator is going to be the same thing. Y plus 5. Again, we're going to highlight, we'll go yellow. 2y minus 3y. So that's going to be negative 1y. That negative is really showing up there. And then we'll do negative 3 minus a positive 7, which is going to be negative 10. And I don't think there's anything we could factor out. We're going to leave that as our answer. Alright, let's go to your left page. Try this one on your own. The sub can hit pause. Alright, the denominator on this one is going to be y plus 1. And we're going to take 11y minus 5. Kind of missing on the highlighter, but you get the point. 11 minus 5 is 6y. And the other ones is negative 3 minus positive 6. So that makes negative 9. I notice the top has a 3 in common, so I'll pull out a 3. And what's left is a 2y minus 3 divided by y plus 1. So what answer does that match up with? D, it looks like. Am I right on that? Yes, D. Okay, try this one on your own as well. Alright, the denominator is going to be x plus 7. And then we take x minus 2x. And remember that there is that 1 there. So 1 minus 2 is negative 1x. 5 minus negative 4. Be careful here. Minusing a negative does become adding. So it's 5 plus 4, or 9. So D is our answer. Okay, now we've got an interesting looking denominator here because they look close, but they're not exactly the same. Now, if this was addition, that wouldn't be a problem because you can switch the order, but you can't switch the order in subtraction because like 10 minus 3 is not the same thing as 3 minus 10. One's positive, one's negative. So here's what we need to do to make them the same. We need to multiply the top and bottom of one of them by negative 1. Okay, and then just for ease of it, I'm going to do the second one times negative 1. This is going to be awful to try to write here. Come on. That's a negative 1. Maybe I need to use the mouse. Here we go. Okay, so now I've got that. Now I'm ready to rewrite the problem. So I'm going to have 3s divided by 11 minus s. We didn't change that one at all. Plus, the top is going to become negative times negative or positive s, 5s. And the bottom, we have to distribute that in. So it's going to be negative s plus 11. So now if we look at this, see if I can highlight, the 11s are both positive, and the s's are both negative. So even though they're switched around, they actually do match. They are the same thing. So when I write out my answer, I can put them either way. I'll just put it as 11 minus s. And now we can just take 3s plus 5s, which is 8s. And nothing that we can do to reduce, so there's our answer. Okay, and then the last one for you to try on your own. So go to your left page, the sub can hit pause again. Okay, and so we're going to have to multiply the top and the bottom by negative 1. Okay, so again, by the magic of the pause button, I just typed in the negative 1s there. And so let's write this out. We're going to have 8n divided by n minus 4 plus negative n over, remember to distribute that negative 1 through, negative 4 plus n. Now even though they're switched around, the denominators do actually match, and so I'll put it as n minus 4, and then 8n minus, remember there's a 1 there, 1n, so that would become 7n, and there's nothing more that we can do there. So it would be C. Now, just looking at that, why is D different? Because even though that the order is switched, the sign, so even though it matches that order, the signs don't match. So that's why it cannot be D. So it could have been negative 4 plus n, but it can't be 4 minus n. Okay, so C is our answer. That is it for the lesson. So you can go ahead and work on your questions and summaries, or you can work on homework number 6.